Hello, everyone. The South Carolina Office of Special Education Services, along with the Transition Alliance of South Carolina, present Using Evidence-Based Practice to Teach Science. This presentation is part of the Summer Transition Camp webinar series. The information and resources contained in this webinar are for general information purposes only and should not be construed as an endorsement by the South Carolina Department of Education.
The presenter today is Dr. Alicia Saunders. She is co-PI for Project Impact, Inclusion Made Practical for All Children and Teachers. She is also an adjunct professor at the University of North Carolina at Charlotte. Dr. Saunders' research focuses on access to general curriculum for students with intellectual disabilities and autism spectrum disorder. She has published several articles and book chapters on general curriculum access and alignment, and has presented on this topic at international, national conferences and professional development for teachers. Today's session is using evidence-based practices to teach science.
Hello, everyone. This is Dr. Saunders here. Today, I'm very excited to share some evidence-based practices to use in your science classrooms. During this presentation, we're going to cover 3 objectives. The first will be to discuss several barriers that secondary students with disabilities may face in science classrooms. We also will talk about incorporating principles of universal design for learning into your lesson planning to potentially eliminate those barriers for all students and to help maximize the learning. We're also going to talk about ways to incorporate instructional changes using those evidence-based practices that we talk about today into your lesson planning to help also maximize student learning. It probably comes to no surprise to you that the majority of students in the US fall below proficiency when compared to other developed nations in the world. And for students with disabilities, they often trail even below those students without disabilities. Let's talk about the performance of students with disabilities in science. In general, the majority of students in the United States fall below proficiency when compared to other developed nations. It probably comes to no surprise to you that students with disabilities fall even below the students without disabilities in the science performance as well. A surprising statistic, however, is that roughly 70% of students in the US are not able to make a connection between the science that they're learning in their classrooms to real life situations or be able to integrate that science into other content areas. This is problematic for students with disabilities, especially because they've experienced failure in schools for so long. They need to understand why the science is meaningful to them in order to make that connection to their real life and to be engaged in the science classroom and motivated to learn. There are many barriers for students with disabilities in science classrooms. Most of the students have language disabilities in reading and writing comorbidly. Many of the students have working memory deficits, attention deficits. They have limited background knowledge and experiences, weak math skills, difficulty with language comprehension, and difficulty with self-regulation. Can you think of additional barriers that haven't been mentioned on this screen that your students have experienced in class? Here are some additional barriers that students may experience in a science classroom in particular. First and foremost, there's very difficult vocabulary in science, which is needed for students to be able to perform successfully on assessments and be able to do the labs in the classroom. Many of the textbooks are written well above their reading level, which makes comprehension of the text difficult. A huge problem in many science classrooms is that teachers rely upon lecture to teach science. And in addition, teachers use textbook-driven activities to teach key terms, moving back to that vocabulary point in the beginning. So teachers often will say, well, look in your glossary, find the word, and copy the definition in your notes. This is a very textbook-driven method that often is difficult for students with disabilities to be able to complete. So for students to overcome these barriers, they have to have high quality, explicit instruction with repeated opportunities for practice in order to be successful in a science classroom. Here's a little equation for you to help you remember how to create successful learners in your science classrooms. Today, we're going to talk about incorporating principles of universal design for learning and combining that with evidence-based practices that we know work for students with disabilities in science classrooms. So let me talk a little bit about universal design for learning. You may have heard of universal design before. Universal design was created so that people could access different areas of life. For example, a curb cut makes it easy for a wheelchair to go onto a sidewalk. A curb cut also is very helpful for a mother with a stroller or a delivery man who is pushing a cart onto the sidewalk. Likewise, universal design for learning is a proactive approach where you design your lessons from the top down, incorporating these principles so that your students can incorporating these principles to minimize barriers and maximize learning. The goal is to develop expert learners who are independent, resourceful, and self-directed. There are 3 key principles of universal design for learning that we will talk about several times in this presentation. The first is multiple means of engagement, multiple means of representation, and multiple means of action and expression. I'm going to go into those a little bit further. So you'll see here at the top, these are the 3 key principles: multiple means of engagement, representation, and action and expression. Vertically, these guidelines are organized into the 3 principles, the color-coded shades that you see. Each of these principles is broken down into guidelines. There are 9 guidelines that you'll see here in yellow. The guidelines are organized horizontally. The access row at the top includes guidelines that suggest ways to increase access to the learning goal by recruiting interest and by offering options for perception and physical action. The second row, the build row, includes guidelines that suggest ways to develop effort and persistence, language and symbols, and expression and communication. Finally, the internalized row includes guidelines that suggest ways to empower learners through self-regulation, comprehension, and executive functions. Each of those guidelines that I just discussed have subpoints below them. These are called checkpoints, and there are 31 checkpoints to consider when you are designing your lessons. That's not to say that you have to include all of these guidelines within your lesson, but you should mix and match them to meet the learning goal. I've included a QR code on the screen to help you access this graphic organizer so that you could easily download and print it, or dig further into what each of these checkpoints mean. By applying the principles of universal design for learning, the guidelines, and the checkpoints, you will reduce barriers for your students and maximize learning opportunities for your students. So going back to the original equation that I discussed, we talked about incorporating principles of universal design for learning and evidence-based practices into your lesson planning. Often these are thought of as 2 camps, but they actually don't have to be thought of as 2 different camps. And I will show you when we discuss the evidence-based practices, how many of these evidence-based practices for your students with disabilities also meet the needs for all learners in the classroom, particularly if your students are included in a general education science classroom. So the evidence-based practices that we will talk about today will help to overcome many of the barriers that we discussed at the beginning of this presentation. The first evidence-based practice we're going to talk about is to make science meaningful for your students. The second is to use guided inquiry-based instruction with explicit instruction. The third is to use visual supports. The fourth is to use evidence-based practices to teach key vocabulary and concepts, and we're really going to dive deep into this strategy. And finally, we're going to use frequent opportunities to respond. So evidence-based practice number 1, making science meaningful. At the beginning of the presentation, I shared a statistic that 70% of students are not able to relate the science content they are learning to their real life or apply it to other content areas. I mentioned that this is very important for students with disabilities in particular because we want to cultivate that interest and motivation, especially for learners who may have experienced failure up to this point in their educational career, and we really want to make sure that they are motivated to learn in your classroom. So the first thing you want to do is really build in discussion on how this relates to their real life or to the world. We call this anchoring the instruction. One method for anchoring the instruction is to use a quick video to show students how they can use this in their everyday life or how it impacts them in the world. For example, you might choose a video from Discovery Education, or your students may enjoy going back to Brain Pop videos or even Bill Nye the Science Guy to really get an idea of how the science is relevant to their lives or how it could be used to make the world a better place. Another idea is at the end of your lessons, have your students reflect on those 2 key points. How is it relevant to their life or how they could use it to make the world a better place? Now, I mentioned that the evidence-based practices and the universal design for learning could be used together. They aren't necessarily 2 different camps. So here's an example. Making science meaningful meets the multiple means of engagement UDL guideline. It provides options for recruiting interest, and it meets the checkpoint optimize relevance, value, and authenticity. It also meets the multiple means of representation principle. The guideline provide options for comprehension, and the checkpoint activate or supply background knowledge. The next evidence-based practice is inquiry-based science using a guided approach. So in science classroom, inquiry is the goal. And inquiry is a broad topic that is often has many different definitions. There really isn't a solid definition for inquiry, but Scruggs and Mastropieri in 2007 defined inquiry-based instruction as the comprehension of content knowledge that emphasizes the depth of learning and comprehension of relevant concepts. Inquiry-based instruction can help students focus on the big ideas in science and develop the ability to reason scientifically. Inquiry-based instruction also has other synonyms such as hands-on science. For students with disabilities, they may need a more guided inquiry approach, using explicit instruction to help them succeed when learning new and complex content. In the next few slides, I'm going to illustrate key components of inquiry and how this can be differentiated based on students' learning needs. Before moving forward, I want to point out how this evidence-based practice using the guided inquiry approach also meets the principles of universal design for learning, action, and expression. It meets the guideline options for expression and communication with the checkpoints using multiple media for communication, using multiple tools for construction and composition, building fluencies with graduated levels of support for practice and performance, particularly that last guideline. In addition, it meets the universal design for learning principle of multiple means of representation by providing options for comprehension, and it helps students guide information processing and visualization and maximizes transfer and generalization, which really is something that's very important for students with disabilities. At the end of the day, we want them to be able to apply this to their everyday lives. So here is an example of how you can differentiate inquiry in your classroom. Now I've placed a gold star above the ideal location for where you want students to be. The first principle in inquiry-based instruction is the learner engages in scientifically oriented questions. And that we want the learners to pose the questions. We want learners to have awe and wonder about their natural world and be able to ask questions about their natural world. But for many students with disabilities, this is a very far stretch. We need to provide a little bit more explicit instruction on how they can develop those questions. So on the far right, you'll see the most intensive guided inquiry approach. And in this one, the learner engages in a question provided by the teacher using materials provided by the teacher or another source. So you'll see it's a total opposite end of the spectrum, from the learner posing a question down to the learner is provided the question by the teacher. You'll see the diagram at the bottom. The amount of learner self-direction varies. On the left-hand side is the more learner self-directed, and on the right-hand side, there's less learner self-direction. On the contrary, there is more teacher direction on the right-hand side than there is on the left-hand side. The second inquiry approach is the learner gives priority to evidence in responding to questions. So in the self-directed approach, the learner would determine what constitutes evidence and collects it. That's the ideal location for students to be at. For our students, they may progress from the most intrusive on the far right. The learner is given the data and told how to analyze, or it may be a little less guided. So the learner is given data and asked to analyze the data, or even less guided, where the learner is directed to collect certain data. So it falls on a continuum of where students are provided with support. The same applies for the third principle of inquiry-based instruction. The learner formulates explanations from evidence. The more student-directed version is they formulate those explanations after summarizing evidence, and then the most directed inquiry approach is the learner is provided with that evidence. The fourth inquiry essential feature is that the learner makes connections to scientific knowledge, and you'll see the continuum on the screen. And then finally, the fifth inquiry essential feature is that the learner communicates and justifies explanations. So again, just to show you an illustration, many students may need to start on the most intrusive guided inquiry, where the learner is given steps and procedures for communication and then progresses along the continuum. The goal may be for you to, as a teacher, to start on the far right side, providing the more intensive instruction. And then as you progress through the year, move across the continuum to lessen your teacher direction and increase the amount of student direction, thus increasing that self-determination. The third evidence-based practice that I am going to talk about is providing visual supports. And I'm sure many of you already do this in your classrooms. There are 3 different visual supports that I provided on the screen, and I've kind of chunked multiple categories within the term visual supports. On the left-hand side, you'll see 3 icons, and these are things that could be easily embedded in your PowerPoint presentation to serve as a stimulus cue to just give your students a heads up that something important is coming. So, there's new vocabulary that we're going to introduce in the PowerPoint, and using this icon in your PowerPoints consistently across your lessons or whatever platform that you're using. Or there's a key point that we're going to review that would signal students that this is something that might be assessed on an assessment later. Or it might be you might have a picture icon for taking good notes to signal that this is the time that they should pick up their pencil and start writing. Again, these are just good reminders for the students to help them, in addition to maybe even using a verbal prompt to the students. We're going to discuss some key vocabulary, but they also have this visual representation. In the middle, you'll see 2 different types of visual supports that you often see in classrooms, and I'm sure many of you are using these. The top one is an anchor chart. It's just a sample that I downloaded from the internet. Anchor charts are great ways for students to be reminded of some key ideas within the lesson. And then below that are the graphic organizers. So this is a KWHL chart, which is probably a little bit of a variation from the KWL chart that you've heard about in the past. The H is how I will find out. And this is a critical feature in science because it really, this fosters the guided inquiry approach. This helps students go through the steps of science inquiry. On the right-hand side, you'll see 2 diagrams, and these are for plant cell components and for photosynthesis. The reason that I put these here is that these are really critical for vocabulary acquisition. So what I want you to do is to pair all of your vocabulary terms with some type of diagram or picture for your students to help them better remember. In the beginning of the presentation, I mentioned that many teachers will use that lecture and then the text-based approach where they'll have students look in the glossary and copy down the definition. And this is one of the pieces that's missing. This is the piece that will help those students create that picture and make that connection in their brain. So by having the representation, the visual representation paired with the definition, the students are more likely to acquire that term. And it probably is no surprise that visual supports also meet universal design for learning, the multiple means of representation, by providing options for perception. In the guidelines, it offers ways for customizing the display of information, and it offers alternatives for visual information, which is very important for students who come from all different backgrounds and have all different needs. The graphic organizer at the bottom, the KWHL chart, meets the universal design for learning principle, multiple means of action and expression. And it provides options for executive function, supporting planning and strategy development use. This is really important for learners with disabilities because they have those working memory deficits, and also they have trouble often with executive function tasks. So providing them with something like this will only help their comprehension by giving them a map of how to comprehend what they are about to do, maybe in a lab, or even what they're inferring from a text. The next evidence-based practice that we are going to discuss is how to provide explicit vocabulary instruction. And I am going to give full credit to Dr. Michael Kennedy's website, www.spedintro.com. He is a professor at the University of Virginia and has fantastic videos that I encourage you all to check out. It's a great resource for how to do explicit vocabulary instruction, not just in science, but in other content areas as well. And each of these videos are very short. They provide step-by-step directions on how to do that, and then he provides a model for you to emulate in the classroom. He also has unedited clips of teachers actually performing many of these strategies within their classrooms. So please check it out, and there's a QR code for quick access. For the fourth evidence-based practice, explicit vocabulary instruction, there are four key methods that we're going to discuss, and then the fifth one I'll talk about in just a second. So first is student-friendly definitions and reviews of key background knowledge. The second is using examples and non-examples. The third is breaking terms into morphological parts. And the fourth is exploring semantic relationships between terms and concepts. The fifth one I have starred because it's having discussions about term meanings will be applied to each of the 4 strategies listed above and should be incorporated to in your classroom multiple times a day. Again, at the bottom, I have just a little prompt to make sure that you're using that explicit cue, that visual support for you and your student to remember, oh, there's some brand new vocabulary coming up. Or when you're teaching explicit vocabulary instruction, repetition of the vocabulary is critical. You need to think about how often your students are hearing examples and how often they get to demonstrate their learning by answering questions. Research shows us that students need 12 different exposures to a term within that classroom before they can be expected to master it. So this could be over time, a couple of days, or even within one session. Think about this as a menu of options to use. You may use some of these for some words, you may group some of these for some words, or you may only choose to use one strategy for other specific words. Explicit vocabulary instruction meets the universal design for learning principle of multiple means of representation by providing options for language and symbols. It clarifies vocabulary and symbols, it clarifies syntax and structure, it supports decoding of text, mathematical notation and symbols, well, really decoding of text. It promotes understanding across languages, and it you can illustrate these using multimedia. It also highlights patterns, critical features, and big ideas and relationships, which are critical in science. So the first strategy that we're going to talk about is the importance of student-friendly definitions. The reason that we're starting here is that many of the textbook definitions that you would see are very cumbersome and difficult to remember. On the left-hand side, you see the definition of an atom. Now, this is pulled, I think, from Wikipedia off the internet, but you'll see that the definition is very complex, and that would be very hard for even me to remember. Rather, on the right-hand side, there's a student-friendly definition, the smallest whole unit of matter. And it's also paired with a picture to help with that visual support. This is going to be much easier for a student to remember. And the purpose of using these student-friendly definitions is really to reduce that complexity and to build that background knowledge, to make that connection with the learner's brain. Now, it's critical that we start with these simple definitions. And I'm sure many of you are saying, well, they're going to be assessed on the formal definition. And you are right. They will be assessed on the formal definition. But we want a starting point to really make that connection in their brain so they can acquire that term and even maybe move into fluency stage of learning with being able to recall that definition. And then we would introduce the more complex definition. But as a stepping stone, we're going to start with that student definition to help them understand it a little bit better. And any time that you're going to introduce vocabulary, I mentioned before that I want you to use that visual prompt, that there's some key vocabulary coming up. You're going to start with a simple definition first, the student-friendly definition that you may have done through a discussion. Then you're going to provide that more in-depth definition once students have a good understanding of that. And then finally, you're going to confirm learning by asking questions. So you're going to check on whether or not those students have a good understanding of those definitions that you've come up with. Now, here's something to think about. Repetition of vocabulary is critical. When you're planning instruction, think how often your students are hearing examples and how often they get to demonstrate their learning by answering questions. These are critical because research shows us that students need 12 exposures of a term before they are expected to master it. So 12 exposures, not just one time that they're copying the definition, or not just one time of hearing the student-friendly definition, but multiple opportunities to hear the definition used throughout that or your class. They need multiple opportunities to hear those student-friendly definitions and the more complex explanations throughout your class. The second strategy for teaching vocabulary, in addition and building on to the one that we just talked about, is to use examples and non-examples. This is very relevant to science. What you're really doing here is you're building a concept. So what is that concept and what is not that concept? First, the students have to start out learning that student-friendly definition and maybe even having a discussion about the more complex definition. And then you're going to show a clear contrast between an example and a non-example. So on the right-hand side, I've given you an example. Select the following that show human-environment interaction. This is where the human is doing something to the environment. So for example, cutting down trees, yes, that's human-environment interaction. A waterfall, no, not a human-environment interaction. On the right-hand side, oil rigging, yes, human-environment interaction. So this just, you would go through and provide many examples and non-examples of when this concept applies and when it does not apply. And then finally, you're going, again, to confirm the learning by asking questions with your students throughout your class. The next approach is called the morphological approach. Basically, what you're going to do is explicitly break down the word into a prefix, root word, and suffix. Now, some words are not going to have all three of these. They may just have a prefix and root, and that's perfectly fine, or a root and a suffix. But the ultimate goal is that you're going to break down the different parts to help them easily be understood by the student. So on the left-hand side, I've given you a picture. This is from Michael Kennedy's talk. First, you introduce the prefix. So the prefix is bio. You'll provide a student-friendly definition. Bio means life. And you might give other examples. So we've heard of bio in the word biology. We've heard bio in the study of biomes, and just making that connection with students with prior learning concepts. Then you're going to ask questions. What does bio mean? It means life. Next, you're going to introduce that root word. So again, you're going to work with providing a student-friendly definition. So the root word is degrade. Degrade means to break down. And then you're going to ask the students questions about what does degrade mean. Maybe you show multiple pictures of what different things degrading in nature. And then finally, you're going to introduce that suffix, able. You're going to provide a student-friendly definition, give other examples like you see on the screen, impossible, unable, and then you're going to have students follow up, and you're going to follow up with questions. Then you're going to put the word all together and then help the student understand the meaning of the word better, which means the ability to break down living things. The final strategy for explicit vocabulary instruction is exploring the semantic relationships among terms. Now, many of the words that you come up with in your class often will be taught within the same unit, but they can be very confusing for students. The example I have at the bottom is mitosis and meiosis. These are things that can get very confusing for students. So in this strategy, you're going to use the other strategies first. You're going to create that simple student-friendly definition. You're going to provide examples and non-examples. But this is, again, to alleviate the confusion between terms that are very similar and that may be taught within the same unit and require some type of background knowledge. First, you're going to provide your signal, which could be that little vocabulary icon that we've discussed. Review the student-friendly terms. And then aid the students in a think aloud about the similarities and differences between the terms. So for example, mitosis is, or a similarity between mitosis and meiosis is that they both are cell division. The difference between these two is that mitosis is the cell division into two identical cells, whereas meiosis is the cell division that results in 4 sex cells. So here you would talk your students through that think aloud process. Explain how and why students might find these confusing. They look the same, they sound the same, and then confirm understanding by asking your students questions to make sure that they understand. Evidence-based practice number 5 is to incorporate frequent opportunities to respond. So you want to have multiple discussions and checks for learning throughout your entire classroom session to really know how your student's performing. What you don't want to do is wait till an assessment to determine if a student understands concepts or not. And the way to do that is to use these frequent formative assessments in your classroom just to check for understanding. One of the most common ways is you might call on a student to answer them, or you might call on a student to answer a question. What happens with teachers often, though, is that they tend to call on the same students, or students that are high flyers, or students that sit in close proximity to where they're sitting. And often the students who are in the back of the classroom, or if they're in an inclusion classroom, the students with disabilities don't get an option to respond. One remedy for this is to draw popsicle sticks or use some type of randomizer to find or to select the name of the student. So you can a digital spinning wheel with the names of your students to select the student, or if you are an inclusion teacher and you have students with disabilities in your classroom, perhaps you and that student come up with a signal to indicate if that student feels comfortable answering the question. So if they give you a thumbs up, then you know that when you ask that question, that student can provide the answer, and that could be their turn for sharing. Some other simple strategies for check for understanding would be a thumbs up, thumbs down. And especially as many of you are doing e-learning as we start the school year, this is a great way to do in video conferencing. Response cards or using whiteboards. I love the whiteboards that you can erase. You can do a 3, 2, 1, show me, and the student can show you the whiteboard. Using think, pair, shares between partners or within groups is another critical strategy. Some other ones that I really love that students often are very engaged using are Kahoot, which is a game that you can download on any phone or iPad or tablet. Boom cards are a newer item that are online where students can be given selected response options to choose from. Google Forms, you can use those as exit tickets. If your district has something called Poll Everywhere, it's a similar system to Kahoot. You can have students create and record things. They can upload those into your learning management system that your school system uses, or something like Seesaw. And then finally, students can do things like build things. So they might build a presentation that they share, or they build a diorama to show their understanding. So the most important thing is that you're doing this frequently and often. And this also provides you with an opportunity to provide more frequent and immediate feedback to students on their learning. And we know that that's a critical component of explicit instruction. Now, frequent opportunities to respond and frequent opportunities for feedback meets the Universal Design for Learning principle, action for action expression. It provides opportunities for physical action. You can vary the method for response and navigation. You can optimize access to tools and assistive technologies, and provides options for executive functions. So enhancing the capacity for progress monitoring for you to see how your students are performing. You are using one type of opportunity to respond right now using the guided notes approach. This is a great strategy for students with disabilities. Often when you say take notes for students with disabilities, they either won't record anything on the paper because they're just so frustrated, they don't know how to write, or they need a word bank. The spelling is a big inhibitor. But if you can provide them with a more structured guided note approach, like the one you see on the left-hand side of the screen, the student may be more successful in taking notes. In guided notes, the blanks typically are preserved for the most pertinent information that you will cover. And just be mindful of students' needs. So some students may have difficulty copying from a model, so you might need to provide them with a desk copy that they can copy into theirs. Some students who struggle with spelling may need a word bank to work from. In summary, we talked about incorporating universal design for learning with evidence-based practices to create successful learners. Just keep this diagram in mind as you are approaching designing your instruction so that you can incorporate strategies for universal design for learning and those good evidence-based practices that we know work in order to maximize your students' success. There's just the tip at the bottom. If you incorporate these principles of universal design for learning and the evidence-based practices, you will definitely be working harder and not smarter. Remember, this is a proactive approach to start your lesson to prevent those barriers from happening, rather than a reactive approach where you're having to do a lot of remedial teaching. So here's my activity, and it's sort of a challenge for you all. One thing I want you to do is to pull a science lesson that you have already taught in the past, and you're going to take a minute to review that science lesson. The first thing I want you to look for are areas where you can incorporate more evidence-based practices that we discussed. Can you make a connection to real life or explain how this impacts the student, particularly at the beginning of the lesson, to hook them and be more motivated to learn that content? Did you use visuals in your lecture notes? Remember those stimulus prompts, those little pictures to help you remember? Did you have visuals on the wall, like the anchor chart? In your vocabulary, not just the definition, but the definition plus a diagram or a picture to help that student make that connection to their brain. Did you use a graphic organizer? This will help with comprehension or even with the student being able to go through the inquiry process. Which leads to my next point. What needs to be changed to use a more guided inquiry approach for struggling students? So if you go back to those inquiry essential elements, are you sticking on the student-led mostly? Or could you move some of your instruction to where it's a more guided approach and then gradually fade that away throughout the year? The next point is very critical. Which vocabulary strategies could be added or used to replace the original activity? So going back to that menu of 5, the discussion and plus something else needs to be incorporated into your lesson. Next, I want you to count the opportunities to respond that you had in the original lesson. How long of a duration passes between your students passively watching you and them actively doing something? We want to increase their activity and their opportunities for expression. Not only does that give you a chance to check their understanding, but it keeps the student engaged in the lesson. And you want them to have no more than 5 to 7 minutes without some type of activity or responding, preferably no more than 2. Finally, review the UDL graphic organizer that I provided on the screen. I encourage you to print that off and keep that wherever you do your planning so that you can look at the different checkpoints and make sure that you're incorporating some of those to help the students meet their learning goals. And finally, this was not covered in my presentation, but I know that it was in several of the other presentations. I want you to look back and embed at least one self-determination skill. Can you incorporate some type of goal setting or some type of self-monitoring of their behavior? I didn't cover task analytic instruction. It's a very effective strategy for students to be able to follow the process, like science inquiry or completing a lab. Perhaps that's some way that the student could have a student-friendly version of that and be able to check off and self-monitor their behavior. That's just an idea. So thank you for attending this presentation. I hope that you will be able to apply those principles of universal design for learning and the evidence-based practices covered to help your students be more successful in their learning and to decrease those barriers.
Thanks, Alicia. This concludes today's webinar. For more resources, be sure to visit the Transition Alliance of South Carolina's webpage at transitionalliancesc.org. Thank you and have a great day.